Yeah. Hi everyone. We are going to see question Subarray maximum of starter 211. Okay. So question is pretty simple. What we are given is a binary string S of length n. Yes, that's the input. Output what you have to generate is a permutation array which contains 1 to n values. Is that right? If you read all this question, if you read all this instruction that is given in the question, you'll be coming up to a conclusion that we'll be given input S and we have to generate a permutation P which contains 1 to n values. Is that right? And that permutation should follow certain rules, and that rules are, just give me a second, that rules are, first rule is this one, that is, if S of I is 1, what does that mean? If S of I is 1, first rule says, can you have even a single subarray in your permutation such that subarray of size I should have I as maximum? What does that mean? Let's take an example. When you see the first character of S, the first character which is 1 itself, you have to have at least one subarray of size 1 where 1 is maximum, right? Where 1 is maximum. And we know that is always possible, is it right? When you're talking about an answer permutation, we can say just have a temporary answer like 1, 2, 3, 4. Yes, in this, there is one subarray of size 1 where 1 is maximum, that is achieved. Even a single subarray, is that right? Even a single subarray will work. Similarly, when you come to 2, the second character is also 1. What does that mean? Can you generate, in your permutation, can you have a subarray of size 2 where 2 is maximum? And we can, is that right? This is a subarray of size 2 where 2 is maximum, we have achieved. But what about this? Here comes the second rule. Second rule says, just a minute. Second rule says, if I is 0, if S of I is 0, not even a single subarray of size I should have I as maximum. What does that mean? Here, I is 3, is that right? There are two subarrays of size 3. None of the subarray of size 3 should have 3 as maximum. That's what it is saying. And we are able to see the first subarray of size 3 has 3 as maximum. That means this is not a valid permutation. Yes, this is not a valid permutation. Now think about it. Yes, think about it. In this, 3 is not fit, is that right? Because 3 is going to be our maximum. What should be placed there such that 3 does not be the maximum for the first subarray of size 3 and the second? Yes. Yes. So we are able to see instead of 3, 4, if I write 4, 3, first subarray has 4 as maximum, second subarray has 4 as maximum. Yes, great. Now what does the last value says? 4. Yes, the fourth character is 1. That means in a subarray of size 4, can you have 4 as maximum? Answer for that is yes. Yes, so this is what the question is saying. And of course, there can be multiple answers. You have to generate any one. Let's look at certain examples which will help us to identify some edge cases clearly. What if I tell you there is a string 0, 1, 1? We are talking about 1, 2, 3. In our answer, what does it specify, guys? What does it specify? It is saying you should not have even a single subarray of size 1 where 1 is maximum. Is that right? You should not have even a single subarray of size 1 where 1 is maximum. And you should agree, no matter what combination you come up with, it can be 3, 2, 1, 3, 1, 2 or anything, 1 has to be present. Is that right? That's what permutation means. If 1 is present in one size subarray, 1 will itself be the maximum. Is that right? That means in this, answer cannot even be generated, which is -1. Yes. Similarly, you should agree, what if all are ones somewhere between and the last is also 0? What does it specify? It is specifying in the entire array, n should not be the maximum. And we all know this is not even possible. Is that right? Yes, because if you are including 3, in the entire array, 3 itself will be maximum. Yes, 3 itself will be maximum. That means in this, also answer is not possible. Yes, so only strings where first character is not 0, last character is not 0, only for them we will be able to generate the valid permutation. Yes, and how it will be simple. Let's take an example where 1, 1, 0, 0, 1, 1 is a string. We are talking about 1, 2, 3, 4, 5, 6 numbers. Our answer or permutation should have values like, let's assume this is what the temporary permutation will be. Is that right? If something needs to be changed, we'll do on this. We know for this it will be correct, for this it will be correct. For this, what should happen here? We are talking about 3 should not be here, is that right? Because in this subarray, 3 will be the maximum. That means this number should be replaced by something greater than 3. Is that right? Only then every single subarray of size 3 will not have 3 as answer. Something greater will be the answer. Yes. Now it will make sense that instead of 3, I can put something larger than 4. But think about it. If I put 4 here, what will happen? Next character is also 0 here. Is that right? That means for 4 size subarray, we will get 4 as answer. Yes. So it will make sense if when I tell you, let's pick a number which will handle all the zeros at once. Yes, all the zeros at once. Yes, that means this is the first point where we got 0, is that right? This is the second point where we got 0. This is the point where we have non-zero value. So it will make sense that first non-zero value, let's put it here, so that everything before the zeros is maximum, which will achieve the correct answer, is that right? What am I talking about? This is 0, this is 0, this is 1. So place it before 3. Our valid permutation will look something like this: 5, 3, 4 and 6. Yes, and we are done. So what am I talking about? Keep track of first zeroth character and substitute, or substitute will be a wrong word, place first non-zero index at x. I'm assuming this to be x at x index, and we are done. Yes, and of course we'll have to do the same thing for others. Imagine if we have few more zeros, right? 7, 8, 9, 10. What you'll do here, you'll say here is the one more substring starting with 0. You'll call this as x. You'll not change anything. Here you have seen that it is 1, is that right? So what you'll do, put 10 at x position. That means your permutation will look something like this. After 6, 10 will be there. Yes, and we are done. That means if you do it correctly, we'll be achieving in the time complexity of just O of n itself. We're not going to discuss the code. Logic should be more than enough for us. Cool. Yeah, thank you guys.